Here we have an example where we're told in triangle ABC, A is equal to 7 units, B is equal to 10 units, and angle A is equal to 30 degrees. And just like in the last example, angle A was 30 degrees, B was 10 units. And so we figured out that the height of this triangle, based on these parameters, had to be 5 units because the height of this triangle, H, is just equal to b times sine of 30 degrees. So in this example, we're told that A is equal to 7 units. And let's see what happens when we try to draw A. We know that A is 2 units longer than the height, and so let's go through all the possible values for this triangle by just altering the angle C. So if I change the angle C, I can see that, and I keep this length equivalent to 7. So I'm trying my best to keep the length of this side A to be constant and not change the length. You can see that this length intersects side C at this position here. Okay. Now, if I rotate it the other way from this position, I see that this side can also intersect, the side A can also intersect side C at this point here. So there's actually 2 positions in this, based on the parameters that we've been given, where side A intersects side C. This point here and this point here. Okay? So there's 2 possible, there are 2 possible triangles in this case. And in this case, notice that also A is greater than B. So in the case that B is greater than A, rather. So in the case that B is, we should say in the case that angle A is acute, so we should say that if angle A is acute and A is, well, let's write an inequality chain actually. And A is greater than B sine A, where this is the height. Oh, whoops, I didn't mean to do division there. I just kind of meant to write one of these. So this is the height. So if A is greater than the height, but A is less than side B, then this is the ambiguous case. Then two triangles are possible. So let's write then two triangles are possible. And when you're solving using the sine law, you've got to take this into account, because based on the parameters that we've been given, there's 2 possible triangles. So I can't just solve for angle B and say that it's one value, because it could be there are 2 possible solutions. And similarly for side C, there's 2 possible solutions for side C. And if you use the cosine law and you solve for side C, you see that you'll be able to see that that's true. Here we'll use the sine law though, and we'll set up this sine law to try to figure out what angle B is. And angle B is either going to be this angle, so this could be B. Let's call this B, and let's call this angle B prime. Both are valid solutions based on the information that we've been given. So let's do case 1, and case 1 will be that B is acute. So we have 2 possible cases. Case 1 will have angle B is acute. And in order to solve this, we'll set up the sine law. So I know that the sine of angle B over B is equal to the sine of angle A over A. B is what we're trying to figure out. Sine B is what we're trying to figure out. Side B we know that it's 10. Sine A is sine 30 degrees. And side A is sorry, I should have labeled that. Side A was 7 units. So this is 7 units, and this is 7 units as well. So side A is 7 units. And we can go ahead and we can isolate for sine B. We know that if we multiply both sides of this equation by 10, we get that sine B is equal to 10 sine 30 degrees over 7. And thus angle B is approximately equal to, if you do this on your calculator, well, let's maybe we should show that. So angle B is equal to the arc sine, or the inverse sine, of 10 sine 30 degrees divided by 7. So angle B is approximately equal to, do this on your calculator, and I encourage everybody to try this on their calculator at home. 10 sine 30, which is 5, divided by 7 is 45.5 degrees. So let's round this to the nearest tenth because the question doesn't specify. So this is 45 point, this rounds to 45.6 degrees. Rounds to 45.6 degrees. So we know that angle B is 45.6 degrees in this case. Now, I assume that since you've already gone through the previous videos, that you'll be able to solve for the rest of, you'll be able to solve this triangle for angle C. You'll be able to solve this triangle for side C as well. So solve based on this information, solve the rest of the rest of triangle. Solve the rest of, let's write, solve the rest of triangle ABC as exercise. So that's case 1, and again from here it's pretty trivial to solve the triangle on your own using sine law. You could also use cosine law if you really wanted to, but it's more work. So just I guess the fastest way to do this would be to solve for angle C and side C using the angle C you can get just by doing 180 minus these two angles. And then you can use sine law to solve for this length C. So I'll leave that as an exercise. Now, case 2. Case 2 is that case 2 is where angle B is obtuse. Angle B is obtuse. And the question is, how do we get angle B? Well, notice that since in this triangle here, the triangle that I've made between B prime, B, and C, this triangle is isosceles. So that means that this angle has to be 45.6 degrees. So this angle is 45.6 degrees. That means that B prime, this angle B prime, so case 2 angle B, or I guess we could call it B prime. Angle B prime is equal to 180 degrees minus 45.6 degrees. Which is equal to 134.4 degrees. So another possible value for angle B is 134.4 degrees. And from there, we could actually go ahead and solve for angle C, and we could solve for, this would be the other possible, this dimension here would be the other possible dimension. Whoops. This would be the other possible dimension for side C. Okay? So we have that angle B would be 134.4 degrees in case 2, and angle C would be equal to 180 degrees minus 30 degrees minus 134.4 degrees, which is equal to 180 minus 180 minus 30 degrees is 150 degrees, and 150 degrees minus 134.4 is 15.6 degrees. So these are the two cases, and then we could go through and we could solve for side C, the side C right here, but I'll leave that for you as an exercise as well.